Welcome back. Today we're going to talk about the properties of reflections. Okay, a reflection is a transformation that flips an image across a line. So in this case here, we can tell what the original image was based on the prime notation of the reflected image. So this is what we call the pre-image. We learned that in the last lesson, and this is the image. Okay. And this green image has been reflected over this red line, which is called the line of reflection. It's been flipped across this red line in order to get the green image. Okay, so to actually perform a reflection, so here we're going to reflect the polygon ABCD over the y-axis. Okay. Now to do this, what we do is a reflection maintains the distance that an image is from the line of reflection, but it just mimics that distance across the other side. So for instance, B is a unit to the right of the y-axis, so B prime is 1 unit to the left of the y-axis. Here A is the same distance, so to get A prime, I count from A to the line of reflection, that's 1 unit, and so I match that on the other side of the line of reflection. D is 1, 2, 3 units away, so I go 1, 2, 3 units away on the left side, and that's my D prime. Always remember to label the new points as you make them. C is 1, 2, 3 away, so I match it 1, 2, 3 away. Notice that C prime and C are on the same horizontal line. So I maintain the horizontal distance that I maintain the vertical distance that C is above the x-axis, but what I change is the left-right orientation of the figure. So here, if I were to connect these with some straight lines here, C to D, or C prime to D prime to A prime, and so on. So here is my new polygon right here. Make this line a little bit straighter. And then if I wanted to, I could, color it in. Okay. So what you'll notice is that the figure looks like it's been flipped over. So if this were on a piece of paper and I folded it across the line of reflection, what would end up happening is this, the pre-image would actually land right on top of the image, right? So this is the pre-image, and it would land right on the image if you fold it across the line of reflection. Now, if we look at the new points, see the coordinates of A were 1, 1, so the coordinates of A prime, we look now, it's -1, 1. Okay, B, the coordinates were 1, -3. Now the new coordinates of B are -1, +3. C was 3, 2 before, now it's -3, 2. And D is now D prime is now -3, 1. So what ends up happening is when you reflect it across the y-axis, now this happened because the pre-image was in quadrant 1, and so the image happened in quadrant 2. So the pattern is look at the x coordinate here. The y coordinates all remain the same. That's because the distance that the point is above the x-axis remains the same even after you reflect it, because you're reflecting it over the y. So you're holding all the y coordinates constant, and what you're doing is you're flipping around the x coordinates, okay, because you're changing the left-right orientation of the figure. So here I just take all the opposites of the x coordinates and I keep the y coordinates the same. That's happening because of the reflection across the y-axis. If I instead reflected it across the x-axis, so let's see, A prime would be here. B is 3 units above, so B prime is 3 units below. C is 2 units above, so C prime is 2 units below. D is 1 unit above, so D prime becomes 1 unit below. So here's my new figure. And what you'll notice here is that all your x coordinates stay the same, right? A prime has, it's 1 unit to the right, B prime is 1 unit to the right, C prime is 3 units to the right, and D prime is 3 units to the right, but all the Y coordinates change. Okay, and that's again because the pre-image started in quadrant 1 and the image itself landed in quadrant 4. All right, if the pre-image were in quadrant 4, it would have, all your Y coordinates would have initially been negative, and then they would have changed over to their opposite, which is positive. Okay, so a reflection across the Y-axis, it keeps all the X coordinates the same, and it changes all the Y coordinates to its opposite. So that is something that you should write in the annotation as you take the notes for this lesson. Okay, if you were asked to reflect across the line y is equal to x, so these two previous reflections, we could actually just do them manually and then get the coordinates. This one is a little different. If you reflect across the line y is equal to x, so this line has all the points where the y coordinates and the x coordinates are the same, so it looks like this, right here. And so this is the line of reflection that I'm suggesting in this problem here. So if you reflect across this line, what ends up happening is it's actually really difficult to keep the same distance because it's a diagonal distance as opposed to here, which was just a vertical or a horizontal distance that we had to maintain. So what you do is actually you do it with the coordinates. Literally what I'm saying is take the y and make it equal to the x. So all you're doing is flipping the x and y around. So here is, all I'm doing is I'm going to switch the coordinates around. So this becomes 4, -3. This becomes 3, -6. This becomes 2, -4. And this becomes 3, -2. So let's plot these points. 4, -3 would be here, and that's our A prime. 3, -6 would be here, that's our B prime. 2, -4. And that is our C prime, and D is 3, -2. Okay, so here let's connect these points right here. And I know it's a little bit harder to see, but if you, again, if you were able to fold this on a piece of paper along the line of reflection, this would flip right over this red figure right here. Okay, and what this also means is that if you were to get this distance from D to the line of reflection, it would be the same thing as the distance from D prime to the line of reflection like this. And if you measure the distance using a perpendicular line from the vertex to the line of reflection, these distances are the same. Likewise with B, if I were to measure B, the distance from B prime to the line of reflection here, and then I were to measure the distance from B to the line of reflection, these distances would be the same, because that's what a reflection does. It maintains those distances that the vertices are from the line of reflection. It just flips it around the line of reflection. Okay, so let's say that you were asked to reflect over a line that's not the x-axis or the y-axis, but it is a horizontal line. Well, what you would do here is, this line, by the way, is actually called y is equal to 1, because all the y coordinates are equal to 1 along this line. This is not necessarily something that you need to know in 8th grade, but in Algebra 1, we do find equations for horizontal and vertical lines. But what you do is you just do the same thing that you've done before, which is you do the reflection first by thinking about the distances the vertices are away from the line of reflection. So, for instance, C is 1 unit above, C prime becomes 1 unit below. A is 1, 2, 3 units above, so you march 1, 2, 3 units below the line of reflection. Likewise with D, that's the new D prime, and B is right here. Okay, so here I can match the coordinates up like this, and there's my new line. Okay, and if you were asked to get the coordinates of the image, then all you would do is just, after you perform the reflection, you would just go back and get the coordinates of the image. Okay, and this is a vertical line, that's not the y-axis, the same thing happens. You would just take D and reflect it over, just one by one, reflecting each vertex. This is 1, 2, 3 units, 1, 2, 3, 4, so we go 1, 2, 3, 4. This is my new D prime. 1, 2, 3, 4, 5, so it's 1, 2, 3, 4, 5. And that makes sense because A is up and to the left, so A prime would be up and to the right. B is 1, 2, 3, 4 units away from D prime, so I can go 1, 2, 3, 4 units away to get my B prime. And C is 1 unit and 2 to the right, so we go 1 unit down and 2 to the left to get my new. So notice I actually didn't reflect B prime and C prime. I just used the other vertices that I had reflected and their positions, and I found the new position. Okay. Now, the properties of reflection. So when you have an image and its reflection, by the way, if you don't know what the line of reflection is, if you've just been given the image or the pre-image right here, this is the pre-image. I know that because it doesn't have prime notation. This is the image. Then all I have to do is count the distance between a point and its corresponding vertex. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's 10 units away. So I know that the line of reflections is 5 units away from either of these vertices. 1, 2, 3, 4, 5. So this would be the line of reflection right here. And by the way, this line of reflection is called x is equal to 3 because all the x coordinates on this line are have the value of 3. Anyhow, what you'll notice about reflections are that the image is always congruent to the pre-image. All right, so the area, all the lengths of the sides are equal, all the lengths of the corresponding angles are equal. So the area contained within, because of these properties, the area contained within is equal. Orientation is not preserved, so the way that the vertices sit with each other, so D, for instance, is 1 down and 1 to the right of A in the pre-image, but D is 1 down and 1 to the left of A prime in the image. So if you're flipping over a vertical line, the orientation is flipped right to left. And if you are flipping over a horizontal line, the vertical orientation has been flipped. Okay, so if you're flipping over a vertical line, the horizontal orientation has been flipped. If you're flipping over a horizontal line, the vertical orientation has been flipped. Okay, and that's a way that you can use to find the coordinates of the points. So if you're looking at a vertical line, if you flipped over a vertical line, what you'll notice is that the x and y coordinates the x coordinates have been changed, but the y coordinates remain the same. And if you are flipping over a horizontal line, what you'll notice is that the y coordinates change and the x coordinates remain the same. Right? And that's the end of the lesson for today.